All right, garbage. So what do we throw away? The greatest component of waste in the United States, probably the same in many industrialized countries,
Rhino.
Yeah.
is paper.
LOL.
Oh, yeah!
Swap them.
Yeah, it's paper. About 27%. Food waste, 15%. This, of course, is one of the original forms of garbage, of waste, of solid waste. My guess is that it has increased more so in recent times, just simply because people are more wasteful with their food. They are not willing to eat as much. Of course, garbage, solid waste increases exponentially with standard of living. We're more willing to throw stuff away, to buy stuff that's in excess packaging, all those other kind of things, pay for convenience when you have a higher standard of living, more disposable income, etc. And food waste is certainly along those lines. Then there's my old buddy yard waste. So here I go again on my soapbox about how people spend too much time taking care of their yards. When else did I talk about how this was an issue when it came to yards and maintenance? There was, yeah, with water, right. Water resources, number one use of water in the Central Florida area is for people watering their yards. And consequently, here's another area in which simply making sure you've got a nicely trimmed, maintained yard, etc., causes environmental impact. Now, yeah, you could make the argument that, well, if you didn't, pick it up and package it, etc., it would still decompose and do the same thing it ends up doing at the landfill. And that's actually true, although they do chop it up and stuff to accelerate its decomposition at the landfill and produce mulch and things like that. However, what's the difference in it happening at your house versus happening at the landfill? That'll be the main difference environmental impact-wise between those two options.
Inside and outside.
Well, yeah, I mean, that's part of it. That's the way they do it. Some of it they do inside a processing facility, but much of it is outside there at the landfill. It's just going to waste and go to garbage and everything. Yeah, Roger? Transportation, absolutely. And this is a big part of a lot of waste management and everything when it comes to what our impact and everything, the environmental impact of these different processes is the fact that you are transporting it, moving along, and that, of course, is going to require use of fossil fuels typically, and the impact of roads and all the other kind of things that comes along with driving this stuff around, and therefore, consequently, doing your own mulching and composting and things like that will reduce the environmental impact in those particular areas. Plus, you don't have to buy fertilizer and other things like that. So, as a matter of fact, part of your food waste also, as you may know, can go into that compost pile that you use at your house, and therefore have a ready supply of fertilizer and not have to worry so much about hauling it away, taking it out to the curb and everything. That's my environmental consciousness there is in the form of laziness, and that I don't want to bag up a bunch of grass and leaves and stuff like that and haul it out to the curb. It doesn't make sense to me when I can just let it decompose in my yard. The next after that is probably the biggest challenge when it comes to solid waste management, and that is plastic.
Wow. Man.
And there's a number of different reasons why plastic, you guys get off your phones please, pay attention. There's a number of different reasons why plastic is a big issue. One, of course, is the fact that plastics are not very biodegradable. They are going to stick around for a long period of time. Another one is the fact that plastics are oftentimes toxic substances. They're toxic when they decompose. They themselves, when they're undecomposed, they're also toxic when things ingest these. It's not super toxic in that you'll get, poisoned by contact with it. Obviously, we make our water bottles and stuff out of it. But ingestion by or other organisms can lead to problems, choking, and other kinds of things. And yes, long-term exposure to these different substances has been linked to cancer and hormonal effects from them. And you probably heard that with using like plastic bottle PCBs and things like that. Same thing happens out in the environment, of course. And then also the fact that plastics, not only because they're non-biodegradable, they stick around for a long period of time, they're light. They're low in density, and therefore not only are they easily carried by the wind, and many of these are going to end up in the ocean, once they're in the ocean, then they float, and that makes it even, or if they end up in like in a river or something like that, they blow there or whatever else, that river eventually goes out into the ocean, it floats, it's going to be transported along the way. If you throw a can, which is not good to do obviously, but if you throw an aluminum can in the water, once it fills up with water, it's going to sink to the bottom and eventually will rot and decompose in there, and aluminum itself is not terribly bad for the environment. It's a natural component of the crust of the earth. Plastics will float out into the ocean, and even though they're low in biodegradability, they do break down. The sunlight, the UV radiation does break them down, and they become smaller and smaller bits of it. And what they're finding now is in the ocean that they're becoming incorporated into the food chain. So these bits of plastic, these literally trillions of tons of plastic that are in the ocean right now, are not only floating out there as big debris and stuff, they're breaking down into microscopic pieces that organisms are eating and consuming, and it's getting into the food chain and getting into the biological systems, and in some cases, like with tuna and stuff like that, it's getting into us. So this is another one of the big problems that we see with plastics and the many different things that they impacts that they have.
So we're slowly killing ourselves.
Well, we're killing the environment. I mean, it's a big part of that, and yes, it comes back. Everything that goes out in the environment, that's a central issue, of course, in environmental science. It's not just about hugging the trees and protecting the bunnies and the other kinds of nice, flipper and all those other kinds of things out there. These are things that affect us, of course, and they're things that we're exposed to. And as I mentioned before, I think that a lot of the medical symptoms that are more common nowadays with MS and autism, lupus, things like that, I think a lot of that can be linked to our exposure to these types of substances on a regular basis. Increased cancer rates as well. So there's your breakdown. Now you may, if you do the math and add up the percentages, you'll see that it doesn't, there's about 20% left over of miscellaneous things like glass and rubber and textiles, fabrics, things like that make up the rest of the garbage. So there's, of course, a wide variety of different things. But these are your main components of what people throw away. Okay. So what do they do with it? So taking your, like I said, the garbage, getting rid of your garbage, moving it away from where you are, putting it in a particular place has been around ever since people have been producing garbage, which means, since we've been living organisms. In the past, of course, you find a place to put all that together, like I mentioned, the piles of shells that are left over from Native American populations. Nowadays, we have to go a little bit further than that, not only because of the amount of waste that we have to get rid of, but because of the type of substances that we put in the garbage now are much more toxic. Whether it is the plastics, or also we've got a lot of metals, so like with electronics and mercury and lead and cadmium and other kinds of heavy metals, all of these toxic substances are much more likely to be in your average garbage bag now than they were even 50 years ago. So we have the limited capacity. There's only so much space for them. But that I want to stress that this is not a huge issue. We have pretty, we still have a fair amount of space to dispose of things, landfill space left. So that's not the biggest environmental issue, but in some cases it's definitely a problem. You also have the NIMBY problem, right? Which is what? Right. People don't want to have a landfill. It doesn't matter that you have plenty of space to put in a landfill. It's not acceptable for a lot of people to have landfills nearby. They smell bad. They attract, vermin and lots of birds and stuff like that. So it's not a popular thing to have in your neighborhood. The big thing now, though, like I said, with all the toxic substances we put into the landfills, I'm going to go ahead and let you have a point. Group A, you went before Group 2, right? Yeah, you were third to go. Because that is a potential issue there, but more of a problem that we have with landfills is groundwater contamination. So I'll go ahead, like I said, I'll leave your point there. I want to write it in here so everybody can see it. So we'll put 8 there also. Groundwater. Because of the toxic things that are in our garbage, rain can soak through it. Something called leachate is just basically water that soaks through garbage. Yum. And that leachate may contain a number of different hazardous substances that can get into the groundwater. And then, of course, that could become somebody's drinking water supply, or is somebody's drinking water supply, and then problems there from there. So probably, so that's landfill. So probably about as long as people have been throwing their garbage in a certain place, they figured out that by burning their garbage, they could reduce the amount of garbage quite a bit. And you know, if it's like food waste and stuff, they can burn off the stuff that things want to eat and everything. So incineration or burning your garbage has been around for a long period of time. It does reduce the amount of space that's necessary. You burn up a lot of that organic stuff, get rid of it. You can produce electricity from burning garbage. It's a common thing, much more common to make these waste to energy type plants, which will burn the garbage and therefore enough, you know, that's going to generate enough heat to boil water and run a steam turbine. The big issue with those is not only they're very expensive, but of course with garbage you have to be very careful what you burn. The potential for air pollution is high. Even if you clean it up quite a bit, there's still a big source of air pollution. They're still going to be putting carbon dioxide in the air, so that's a global climate change issue. And consequently on these facilities, the garbage is highly separated, and the smoke from burning that garbage is highly filtered and processed to reduce the air pollution process as much as possible. So they are very expensive, but they are becoming more and more common. The best thing, of course, to do with your waste is recycling. Recycling is part of this whole process, even though it's not, you know, I'm giving you the impression that oh, this is all the stuff that's going to landfill or getting burned. Recycling is part of that, part of what is taken away from our solid waste. This, of course, is ideal. There are many benefits to recycling. Biggest part probably is actually, though, the reduced amount of raw materials you have to obtain. We've talked a lot about mining, the impacts of mining, and things like that. Also, the fact that there's energy and pollution that's produced in refining them, taking them from the raw materials and putting them into their final product. And then you have landfill space. Like I said, landfill space is not a huge issue. Some areas it is. Some, you know, if you have an island nation, for example, you're going to have, a lot of times they have to pay to get their garbage shipped away from them. Recycling does have some drawbacks. You have transportation costs, of course. And then you have the separation, labor-intensive or automation used to separate your different recyclables into different things. A lot of substances don't recycle well. A lot of times it's easy to get contamination in there that can ruin them. Like I've heard that if you leave a receipt inside one of the grocery bags, that it can blow a whole batch that they, you know, it's no longer usable. I don't know. But what? It means you take your receipt, you know how you take your plastic bags back to the grocery store to have them recycled? Maybe you've heard of that concept? No? Okay, well, you make a big issue of making sure you take the receipt out of there. The paper, I guess, messes up the process. But recycling is obviously good, better than throwing it away, but it is not the best thing to do to reduce your solid waste problem. The best thing to do is to reduce the amount of disposable things that you consume in the first place, and therefore the less you consume, the less is produced. Now this is a concept, by the way, that I want people to understand, because a lot of people have this impression that it doesn't matter certain things how much you use them because they've already been made. I've heard students say this before, why should I save paper? It's already been made, somebody's got to use it, right? Well, believe it or not, the less you use, eventually, at some way along the supply line, the less you will buy, the less will be produced by the manufacturer, et cetera, et cetera. So I just want to make sure everybody's clear on the fact that if you reduce your consumption of certain things, eventually that will mean that less of them are produced, and you know, the raw materials and all the other impacts that come from that will take place. Reusing then, of course, is also ideal to reduce buying new materials of that. And then as kind of like a last resort, recycle. Not to mean that recycling is bad, but it is better to reduce your use of disposable items in the first place. Reuse those disposable items whenever you can. And then at the end of the line, if you still have these disposable items, then recycle them rather than throwing them into the garbage. Questions? Anybody about this? No? Okay. Alrighty, to the dump, to the dump, to the dump, dump, dump. People have been throwing stuff away for a long time. Even other organisms throw their stuff away. They take their waste and they get it out away from them, whether it's their own organic waste, which of course we classify as liquid waste because we typically flush it away, or if it's just the remains of the last meal, the little bits of bone and things like that, or shells. They typically will still have some stuff on them, some food items on them, and therefore they'll attract bugs and they'll start to smell bad. So people have all, ever since they've been eating things, obviously, they've been taking these materials and putting them in other places. One of the ways you can see this is Indian mounds. Now, most people think of Indian mounds, or Native American mounds, excuse me. They think of that they're burial grounds, which sometimes is the case, but it just basically means the remains of a civilization that have still kind of there in their mounds because they tend to be built up. Most of the time, these areas are garbage dumps, and you can actually see them out walking around in Florida quite a bit. If you see what looks like a very old pile of shells sitting up somewhere, if you're out hiking, anybody ever seen that? And they look the shells are very bleached out, look almost fossilized. Anybody ever experienced this? Nobody in here. Well, that stinks. But not anymore because it's decomposed. These are the leftovers of Native Americans, typically, where the shells are very durable as far as decomposition stuff. They can last for thousands of years, and a lot of these times these things are actually thousands of years old. And they're shells from oysters and things like that. Of course, they ate them, and they would pile them up in a certain area, and everybody would come and put their things in the same area because it's, you want something convenient, but you want something somewhat far away from where you were living, and so you would have a common area to do that, and we would call those dumps. That's where you would dump your garbage. So ever since there's been civilization, people coming together, they've been congregating and dumping their garbage in one particular place. So that's not new. But landfills are a little bit more high-tech than that, and one of the things that they do is they try to make things decompose faster than they normally would. And this is the high-tech solution for doing that, is by alternating waste and soil, the garbage and the soil. And they'll pile out the garbage for a day or a couple days. I don't know what the frequency is in which they do it, but they'll do that, and then they'll go and get some fresh soil and spread it over it, and then start the whole process all over again. So how's that for high-tech? That's as high-tech as dirt right there. But they actually, it took a while before people realized this, I guess, or one of those things that some people knew and a lot of people did not. But apparently in World War II, they discovered this particular concept because in war, if you're moving around and stuff, you don't want to leave any garbage behind because that tells the enemy where you've been. So they would spread out their garbage and cover it up with dirt and stuff, and they would find that it would be gone much quicker than if it had been piled together and things. So what's in the soil that's helping this process? Right here.
Bacteria.
Right, bacteria and funguses. Very good. Decomposers primarily live in the soil. As I've been stressing, this is where nature puts its waste, usually organic waste, human and animal and plant waste and everything, goes down, falls down on the ground, goes in the soil, and then it gets decomposed by bacteria and funguses. So putting that on there, and keep in mind that a lot of your waste is still food waste, but paper will also be accelerated in its decomposition, wood, any kind of organic substance, even plastics to a certain extent. There are bacteria that will eat pretty much anything. As a matter of fact, as we'll see, that's one way to try to get rid of certain waste, hazardous materials, by using bacteria. But they will break down. If you've ever, for example, had like a plastic bag or something that was buried in your yard for some reason, just happened to be out there, and you pulled it up, and it's like all falls apart. That's because it was decomposing as well. So this is the primary purpose for doing that layering, and it helps to accelerate that process. And the more decomposition you have, the less landfill space that you need, because it basically becomes carbon dioxide and water vapor goes up into the air. The other main thing that is done at a landfill that is monitored and is checked and balanced and everything else is protecting the groundwater. Because as I mentioned before, this is the number one problem with garbage and with landfills in general, is there potential to contaminate the groundwater. And this is more of a modern problem as well, because of course we throw away stuff nowadays that is much more toxic than the stuff we threw away in the past. Your heavy metal substances, both from batteries and electronics primarily, is where we get things like that, or just things you're not supposed to throw away, like paint thinners and other kinds of things like that. Use motor oil or any kind of oil, petroleum product. And plastics will break down and decompose. Plastics themselves are somewhat toxic, and when they break down, a lot of times they form toxic substances. Yeah, Mike.
What do the special agencies do with petroleum and like paint thinner and stuff like that?
Some of them recycle them, but recycled oil for use in engines has kind of a bad reputation amongst a lot of people. Sometimes they burn it for energy. Those are the main things they do with it to dispose of it. That's the easiest way. As we'll see, used oil is considered a hazardous waste. And with that kind of thing, one of the easiest things to do is to burn it. And like I said, and it's very controlled conditions that, of course, they burn it under, so that they're not getting toxins out in the environment. But they can also harness that energy to produce electricity as well. It's a common fuel for waste to energy generators is used motor oil. Like I said, the number one thing environmentally we have to watch out for when it comes to landfills is contamination of the groundwater from this substance called leachate. And you might want to write this in your note here, is leachate is just basically rainwater or melted snow that soaks through garbage. Yum. How many of y'all have the job of taking out the garbage at your house? That's me. Lovely job. Don't you love when you pull that bag out and all this stuff drips on you and everything, and that garbage juice? Yeah, it's good stuff. So you have that, of course, on a very large scale at a landfill, and if there's toxic substances in a landfill, in any decent-sized landfill, that's going to be the case. And they're soluble. Then the water can leach out the toxins from them. Remember leaching? We talked about this a little bit when we talked about soil loss through acid rain. Leaching is made when water soaks through something and pulls the ions out of it. In this case, we're talking about dangerous ions that could contaminate the groundwater. So to reduce the likelihood of that, they put down a liner, and it is typically plastic and clay, combination of both. Now, the plastic, of course, is for the most part completely impermeable to the rainwater going through it. And then the clay layer is good to reduce that volume. Clay, of course, soaks up water and other materials very well. It's even oftentimes able to pull out the toxins that are in there. And therefore, it's a combination of both as the way that they keep that excess leachate from going into the groundwater. But of course, they have to do something with it, so they will have a leachate collection system, a series of pipes, etc., that direct that leachate away from the dump or from the landfill, usually to a wastewater treatment facility, or they might have an on-site treatment facility for that. So you have a leachate collection system. It's an important part of it. You never know for sure if you catch everything though, so they will also monitor the groundwater. So you have a groundwater monitoring system which consists of wells all around the landfill that on a periodic basis sample the water, bring the water up, and they test it in a lab and everything else like that to look for things like that. You have these monitoring wells, monitoring systems at gas stations. Matter of fact, you might see it. You'll see there's the big plates where they fill up the systems, but you'll see a smaller plate at a gas station, and if you look at it, if you're one of the people like me who looks for change on the ground all the time, it'll say monitoring well, do not fill. That would be a very bad thing if somebody did accidentally fill in there. Probably won't fit into there, but it's and like I said, it's basically a well down into the aquifer, and they dip a bottle down and pull up a collection and then send it off and analyze it. It's one of the primary things that environmental management companies do. So they're of course going to do that at a landfill, And also another issue at landfills, it's an environmental issue because methane, of course, is a greenhouse gas, but it's also, on a larger scale, it's a safety issue, and it has been the source of fires at landfills and dumps throughout history. Have had a tendency to catch on fire, and it's because of this. Anytime you have stuff that's decomposing, you're going to have methane produced. There's going to be anaerobic bacteria that break down those organic substances, and a lot of times their byproduct is methane gas. So you will have a series of pipes and things in that landfill that collect that excess gas, and they'll either burn it off. They burn it because, well, what are you going to produce when you burn that methane? What gas?
Carbon dioxide.
Carbon dioxide. Well, that's a greenhouse gas, right? So that's not good, right?
Well, it's preferable to methane. Right?
Very good, Michael. That's correct. It is a greenhouse gas, but it's not nearly as powerful a greenhouse gas as methane. Methane is on the order of 10 to 12 times more effective at holding energy in, and so consequently, it's better to have CO2 than not. But an even better solution is some of them will capture that and use it. You can use it in tractors and stuff like that as a fuel source, or to heat some area or something like that. So those are the many components of a modern landfill. Any questions about that? No. Okay, hazardous materials. So certain things are too either toxic,
Oh, I got that one right.
or ignitable, corrosive, or reactive. Now, when I say toxic, there's a lot of potentially toxic things that are thrown in the garbage. I'm talking about things that contact with it is going to poison you. Things like radioactive materials, things that if they're directly inhaled, etc., they can cause immediate death from doing that. These are things that are, by law, required to be separated out from the landfill for obvious reasons. You can't just have them being run over by tractors and stuff like that, or be out there getting exposed to the environment and that type of thing. There's a number of different things that can be done to take care of these substances. Some things, for example, like radioactive waste, cannot be made less toxic, and therefore you just gotta have to encase them. A lot of times they will encase them in concrete, or even glass. Glass is used a lot of times because glass is very non-reactive with a number of different substances, and it's actually very, very tough material when you have a very thick supply of it. So glass and concrete are very common things to use for just simple encasement of substances. That's what they do with nuclear waste. Then there are some things that can be chemically neutralized, that they have a counterpart, a chemical counterpart, that when you mix it with that particular substance, they will become less dangerous or less toxic, etc. Of course, acids and bases is a common example of that. There's a number of organic substances that can be broken down with enzymes and other chemical treatments that cause them to be less of a problem, whether it makes them less toxic or reactive, or maybe just makes it so they won't spread out. Some things are mixed, not just encased in concrete, but some things are just mixed with concrete, because then the concrete keeps it from dissolving or spreading around and things like that, even though it's still a toxic substance in there. If it's an organic substance, many of your organic things can be taken care of by burning them. Now, this is important that they're done under the right conditions. So this is when they're taken to a special facility to do that, not just burned in a regular incinerator, because it has to be completely enclosed and everything, and also it is taken care of at very high temperatures with a lot of oxygen. If you remember when we talked about air pollution control, we talked about the fact that burning your materials, organic materials, at high temperatures with a lot of oxygen will cause it chemically to be completely broken down into carbon dioxide and oxides of whatever other substances are in there. And then a lot of those, then like metals, potentially hazardous metals and things, will become ash that can be separated out when you do that as well. So incineration under very controlled conditions and at very high temperatures with lots of oxygen is an effective way to handle a lot of them. This also, by the way, I want to make sure you understand, these are not just hazardous materials that we've got control of, we need to find something to do with this. These also applies to chemical spills. and things like oil tanker leaks and things of that nature, or perhaps a big tanker truck of hazardous materials wrecks on the roadway, or as you know, one that leaks out in the Gulf of Mexico or some other place like that, and they get out into the environment. There's some things we're going to talk about here of ways of dealing with those types of hazardous materials in the environment. And one of them, like I said, with like an oil spill, a lot of times they will burn as much of that off as they can, and that actually helps to get it out of the water and turns it into carbon dioxide and goes up in the atmosphere. There is also, you can use organisms, and we do that, we call it remediation. Now there's, I'm going to take biological, you're on the right track there, so I'll go ahead and give you the point for it. We actually call it bioremediation. And sometimes proteins are used, so I guess I'm feeling generous. And by the way, who wrote that for Group 4? That's very fancy looking handwriting there. I like that.
It was me, actually. Alright, just kidding.
Using bacteria, though, that's the most common thing that's used in bioremediation is using bacteria. Bacteria are basically little chemical factories. When we look at it from in the biological world, there's bacteria for practically any kind of chemical reaction that takes place, particularly with organic substances. There's bacteria that will eat petroleum. There's bacteria that will even separate out and eat or incorporate stuff like mercury and lead and radioactive substances into themselves, and therefore remove it from the environment. Bacteria can also be engineered to genetically engineered to be able to break down and either decompose hazardous waste or make it so that it's no longer as hazardous. And so the process of using that bacteria to do that is called bioremediation. And a lot of times these bacteria will be engineered so that they can only live off of the hazardous waste you're trying to get rid of, so that when they're done with their job, they will die. You won't have these new bacteria that you've introduced to the environment. That's always a problem when it comes to using organisms to try to take care of an environmental problem, is what will those organisms do once they're done taking care of that problem. And in this case, like I said, a lot of times they will go ahead and engineer it such that that's the only thing that they can eat is the hazardous waste. So once they're done with that, they're gone as well. So a lot of use of organisms in that respect, of bacteria. Also the enzymes of those bacteria, that also comes in that category. Usually the bacteria, the way they're breaking down these things is with enzymes. These are protein type catalysts that are very effective at doing things. And so using that by itself, sometimes it's rather than putting the bacteria in there, they'll get the enzymes from the bacteria and apply that. A lot of times those are used on oil spills and things like that, or just things that are spilled out into the ground and into the soil and stuff. And of course, part of the benefit of this is you can spread these things out. You can put them out in the soil or out in the water without completely disrupting. Otherwise, if you had to use any of these methods, you'd have to actually dig it up and take it out. And of course, that can cause a lot of environmental disruption by doing that. Okay. A very similar process known as phyto. What does phyto mean? Not light, that's photo. I know, poo. Yeah. Phytoplankton. What kind of plankton are you've got zooplankton and phytoplankton. There's two types of plankton. One is like a blank that you find at the zoo or zoo, and one is like a blank that you would not. Well, maybe it's a zoo.
Plant?
Plant. Phyto means plant. So you guys need to remember that. Phyto means plant. So phytoremediation uses plants. So bioremediation uses bacteria. Phytoremediation uses plants. And I know plants are biological. I didn't name the processes, but that's what the names of these processes are. And plants can be very effective at absorbing and removing toxins. This was part of what we talked about when we talked about water quality and water pollution and control and things like that. The fact that When you remove plants, that's when you get a lot of water pollution problems. This is one of the reasons why, is because plants can absorb toxins, and a lot of times things that are toxic to people don't bother plants. They can absorb, for example, heavy metals. Now, the problem is if something eats those plants after they've absorbed, mercury or something like that, then they're going to be poisoned from it. But you just have to monitor that and keep it under control. But with plants, you can plant a whole bunch of them in contaminated soil or water, and then harvest them out of there. You take them off, and then you take them to a wastewater or to a hazardous treatment facility and treat them as hazardous waste. But it's an easy way to both absorb the toxins and remove them without a huge amount of environmental impact from doing that, and then dispose of it somewhere else. Okay? Any questions? Alrighty, that's it for hazardous materials.